All right, can you hear me? How's the audio back there? All good? All right. So folks, before we kick it off, here's your chance to participate in our Become a SATCOM Expert game. Please scan the QR code. I think we've got some instructions there. Exactly, Pauline can raise it up. It's a little fun game to become familiar with various SATCOM topics and have a chance to win a prize. I think it's either a Switch or a VR headset of sorts. Exactly, so scan the QR code. I'm going to give you one more chance here, and well, off you go. We'll give the gentleman one more chance here, and then we'll get started. Okay. Well, good afternoon, ladies and gentlemen. Nice to see you already here. Thanks for coming. My name is Markus Islitz-Bichler. I'm the Director of Product Management at Kratos, responsible for SATCOM products. Today, I would like to talk a little bit about Carrier Ethernet. Carrier Ethernet over satellite, what it means, what is it, how does it work, and most importantly, why should we care? So we'll be touching upon a number of topics. First of all, why we're here, why we're looking for new stuff, what are the changes that are happening in the industry right now that are driving us to adopt new technologies and new ways of thinking. There's going to be a little bit of a product pitch here, talking about our OpenSpace family of products, obviously. But most importantly, I want to mention and talk about why Carrier Ethernet? What is it? Why is it important? And we're going to then finish off with a little use case scenario where we're going to look at why Carrier Ethernet is so powerful. What can you do with it? How does it actually work in a real system? Should be exciting. I hope you're going to like it. So let's get started. If I can get the clicker to work. Here we go. So it shouldn't come as a big surprise that there's a lot of stuff going on right now. Our customers are demanding ever more services, ever faster, ever quicker, ever cheaper. That drives a lot of innovation. A lot of innovation, for example, in the satellite space, in the space segment. Mega constellations, multi-orbit operations, software-defined, very high-throughput satellites. There's a lot of stuff going on up there. Furthermore, we're seeing a tighter and tighter integration with the telecom, with the terrestrial telecom world taking place. 5G drives more and more adoption, drives more and more activity, drives higher and higher bandwidths. It's a very interesting time, a very exciting time. However, it does mean one thing. It means that the traditional ground station, faced now with all of these challenges, with these changing business environments and challenges, the traditional hardware-based siloed ground station becomes a bottleneck. How are you going to adjust your operations to a future of software-defined satellites with thousands of beams changing all the time based on user demand? Are you going to go out there into your data center, into your teleport, and rack up one modem after another and rewire them and manually configure them all the time? Nope. We think there's a better way, a smarter way of doing this. And this is what brought us to this OpenSpace, the industry's first cloud-native SATCOM platform. There are three pillars, building one on top of another, that are really driving innovation here, that are all enabling what we're striving for. We're starting off with digitalization. We've heard it now for a couple of years. Diffie, you can see the logo on many stands here. Very popular, very highly adopted at this point. We take the RF signal right at the antenna and digitize it, turning an analog waveform into bits and bytes. What that allows us is to then take the next step forward, to virtualize our processing. We don't need hardware-based modulators, hardware-based demodulators, and whatnot anymore. It can be done in software. We can virtualize these payloads. It's a move that we've seen many times before in other industries play out. When was the last time you saw a hardware-based firewall or a load balancer? Many industries before have experienced the shift from purpose-built hardware to virtualized networking functions running on generic compute. Now it's our turn. So we take the RF signal, we digitize it, and then we run all the processing, the signal processing, the packet processing, all the fun stuff on generic compute. That's all fun, right? And interesting, but what can we do with it? What does it really mean? What does it give us? Well, oops. The real gain is once you start to look at the scale here. We're going to have to provide more and more services ever faster. It's not going to slow down any time. It's not going to get smaller any time. So the question then becomes, how do you operate large-scale SATCOM systems in a modern, dynamic, ever-changing environment? This is where orchestration comes in. Orchestration is what allows you to scale from 1 to 1 million services without changing a damn thing. You're not going to touch your operations anymore. It's not going to be a guy with an Excel sheet anymore. It has to be automated. It's the only way we can survive as an industry. We have to streamline our operations. We have to automate. But luckily also here, there's a pattern we can follow. It's been done before. Look at the terrestrial telecom world. They have managed to scale up their operations, their systems to incredible sizes, and we can learn from them. We can adopt their technologies. We can adopt their modes of thinking. We can do the same thing. We can accomplish the same scale. A very important part of this is open standards. And this is kind of like where the name OpenSpace comes from. We need to get, as an industry as a whole, we need to get out of the habit of reinventing the wheel, of siloing ourselves up and separating ourselves from the rest of the industry. This doesn't work anymore. We're one big ecosystem. We have to be one big ecosystem if we want to survive in this changing environment. An important step towards this is the adoption of telecom standards, carrier Ethernet specifically. This enables us is to provide us a more seamless operating experience and more seamless interoperability between the satellite world and the carrier Ethernet world, and we'll get to that in a moment. So we're digital, we're virtual, and we're orchestrated. At that point, we're cloud native. And what that allows us is to get to the ideal, and my clicker again is, here it goes. That allows us to get to automated service delivery, because this is really the goal. Digital is fun, virtual is fun, orchestration is fun, but it's really, what's the end goal? We want to automate our operations. That's really what we're after here. That's the end goal. That's what we need to achieve parity. This is what we need to achieve competitiveness with the telecom operators. Sorry, I'm getting some feedback here that I'm to hear better. I guess that's why I'm in product management and not in audio production, but all better? All right, sorry about that. So automated service delivery, that's really what we want, right? We want to get away from manual process. We have to get away from manual processes. Look at Starlink. You think they have a guy somewhere waiting in the NOC for a user terminal to show up to log it in? So I was mentioning telecom standards, and I mentioned the title, obviously, carrier Ethernet. What is it? Why does it matter? For too long, the satellite industry has been siloed up. We've had our own. I'm getting a bit of an echo here. Still is. Okay. For too long, we've had our own siloed up proprietary systems. Everybody had their own definitions of what is a service. How should QoS work? How should we actually define the services that we provide to the end customer? That has to stop. And it can stop. There's a clear path forward, and with OpenSpace, we're taking this step forward. We have, from the get-go, as we built OpenSpace, decided to adopt terrestrial telecom standards as our baseline, as our foundation. Specifically, MEFs, the Metro Ethernet Forums, carrier Ethernet standards. It's a large set of different standards concerning data link traffic, concerning orchestration. At the end of the day, what it boils down to is it's a common vocabulary of how services, connectivity services should look like, how we should talk about them, how they should be defined, what they should do, how they should behave quality of service, for example. This is important. This allows satellite operators and satellite service providers to go out and interoperate with terrestrial carriers seamlessly, speak the same language. As you can tell, I'm not American, I'm European, I live in Norway, but I regularly work with my American colleagues, and when we have small chat, it's weird, right? You've got feet, you've got meters, you've got... All right, shall we try this? Right. So, as many of my colleagues can attest to, we do small talk, we talk about the weather, we talk about, oh, it's 80 degrees Fahrenheit, I don't know what the heck it is. I have to convert it to Celsius, and I have no idea how that works, so I have to Google it. Same thing for feet and kilometers and whatnot. Nobody likes converting. Nobody likes to change the line of what Carry Ethernet allows you is speak the same language. There's no reason for satellite operators and satellite service providers to be special, need special treatment. We can adopt terrestrial standards, use the same language, follow their models of thinking, their ways of thinking, and thereby lower friction, lower overhead, lower costs, streamline processes, get to market faster, come up new business opportunities. And this is, at the end of the day, drives business. Save time, increase revenue, reduce costs, and scale seamlessly. Now, let's be a little bit more hands-on. Let's look at a use case, a specific example that we see at many times, many of our customers. What does it actually mean to use Ethernet over satellite? So let's say you're a global enterprise with branch offices around the world, most of which you can reach easily by terrestrial means. What typically do is you would contract with a, oops, here we go. What you would usually do is you would contract with a global telecom service provider to provide connectivity between all your various sites, factories, your mining locations, your branch offices, your stores. And it's all nice and dandy. We all know how to get there through terrestrial means. We know how to configure it. We know how to get there. There's a problem. There it is, the red-haired stepchild of global connectivity, satellite. If you're a global telecom service provider and you're connecting hundreds of sites and there's one or two sites that cannot be reached terrestrially and need satellite, you gotta pick up the phone. You gotta make a request. You gotta talk with your satellite service provider partner. So how do we do this? I need this and that many megabits, this QS. Wait, what do you mean? No, it's good. There's a reason why satellite was always looked at as a means of last resort the terrestrial telecoms, and it is this unnecessary, in our view, unnecessary friction of trying to adopt satellite operations into terrestrial networks. Now, however, if you, sorry, the beep is a little bit today. Here we go. However, what adopting terrestrial telecom standards allows you to do is remove that friction, elevate your satellite operations to a level playing field with the terrestrial providers. Use the same methodologies, use the same tools, the same orchestration, the same interfaces, the same APIs. You're gonna fit seamlessly into the terrestrial operators' workflows and systems. And this is what's gonna give us all of these advantages that we looked at before. Standardized service definitions, automated service management, transparent end-to-end quality of service. But there's more. Carry Ethernet, the mode of transport, more in addition to just moving interoperability between the various carriers, also opens up an entire ecosystem of third-party applications and opportunities for you. Oftentimes, when we deploy connectivity around the world, we're going to end up in situations where there is a terrestrial line available, there is terrestrial connectivity, but it's not reliable. There are outages, there are interruptions. In many use cases, that's not acceptable. That business continuity can drive high SLA costs, penalty fees, if connections are interrupted. That's where satellite. So what happens if we have an outage on a terrestrial line or an important branch office? One thing that the adopting Carry Ethernet standards allows us is to seamlessly operate or seamlessly integrate our satellite modems with third-party value-added applications from the telecom space, such as WAN. Just SD-WAN. Sorry about that. So here we go. Terrestrial line interrupted. What can we do to resolve the situation? Well, in situations, the terrestrial carriers will detect the outage, and by using automated systems, using the standard APIs that the satellite providers can offer them, can request backup links in just minutes. This is the power of interoperability, right? Global telecom service provider was the outage, requests a backup link from the satellite operator, backup link comes up, and by the power of Carrier Ethernet, we have the ability to bring in third-party applications such as SD-WAN, Cloud Junction, Versa, whatever, seamlessly reroute traffic from the interrupted line, satellite backup link in minutes, all automated. Get reliability, get automated service management. Again, we're elevating the satellite operator, the satellite service provider, from a measure of last resort, an equal partner to the terrestrial carriers. Well, now you might be wondering, well, sure, this all sounds interesting, but how does it actually really work? This is where this whole OpenSpace thing that we're talking about comes in. So same scenario here. A branch office, a terrestrial connection to headquarters, all fine, all dandy, everybody happy. You might notice one thing in here, the open edge on the right side. What is that? Well, some of you might have been at my colleague Tobias's presentation earlier today about the open edge. It's our virtualized SATCOM platform running on the edge, deployed in a UCP. What's really interesting about this is this open edge, we can run not just virtual modems for SATCOM, we can also run third-party applications such as SD-WAN. How does this all look? How does it all come together? So, default, we've got our terrestrial line up and running. Traffic goes through the open edge, goes into the terrestrial line, MPLS, for example. Everybody's happy. Here we go again. We again destroyed the line. Oops. What can we do now? Well, the service provider discovers the outage as usual. We have monitoring built in, standard expectations, it's table stakes at this point. And using, again, automated service provision through the APIs that we talked about. Have carrier Ethernet APIs, standardized interfaces for requesting services. The telecom service provider can go to the satellite service provider and request a backup link immediately. There's no manual intervention necessary. There are no negotiations necessary. It's a fully automated workflow. The satellite service provider in this case is using OpenSpace, our SATCOM platform, our virtualized SATCOM platform, which natively supports Carrier Ethernet standards. The service request coming in from the terrestrial carrier is natively understood, processed by OpenSpace. OpenSpace understands their requests for not many megabits, this QoS, and I need it now. So what OpenSpace can now do, it's a full virtual system, it can spin up the necessary processing, the modulators and demodulators and packet processors in minutes, automatically in the cloud, on-prem, hybrid cloud, doesn't matter. It can spin up all of these workloads in minutes, zero touch, no intervention, no human intervention necessary. And that way, we can bring in the open edge to a network, into a SATCOM network, and the SD-WAN solution, automatically which is deployed on the open edge, will automatically reroute traffic over the newly established satellite link, seamlessly balancing traffic between the available connectivity services. Once the terrestrial outage is then resolved, we're able to just tear down the satellite service, responding workloads, release the resources, use them for something else, or running this in the cloud, we can just shut down the virtual machines, save money, we're done, finished. Perfect demand scalability. So it was still fully abstract, right? It's all just a diagram. Can we look, does it actually look in practice? Well, here are a few screenshots from our system in action. So as the service request comes in, as the telecom service provider comes to the satellite operator and says, I need a backup link. I need it now. I mean, that are so and so many megabits now. We have a dynamic frequency planning system in place in OpenSpace. This system will take the service request, calculate megabits to megahertz. It will figure out what frequency to use, what spectrum to use for the corresponding endpoint for the OpenMatch remote. It will pick the right frequency for that. This is what enables automation. There is no manual planning necessary, no negotiations necessary. Oh, where can I put that carrier? None of that. We don't have time for that. As a next step, OpenSpace, this is a screenshot from our system ops center, the RNMS. OpenSpace then starts up these virtual workloads, virtual networking functions, modulators, demodulators, traffic adapters, and it will bring up the physical carriers. It will start transmitting, start receiving. This is a screenshot where you can see the spectrum and the constellation plot. And finally, on the OpenMatch side, success. We've reestablished the connection, see traffic flowing. So, to summarize now, what is OpenSpace all about? What is Carrier Ethernet all about? At the end of the day, it's the customers. The customers need to have reliable, transparent, end-to-end connectivity, no matter the physical medium. Doesn't matter if it's fiber, doesn't matter if it's microwave, doesn't matter, shouldn't matter if it's satellite. It just has to work. It has to work the same way everywhere. And that's the power of adopting standards in satellite. It gives you this guarantees, these promises, this transparency. You know what you're going to get. As the satellite service providers and the satellite operators, we're an important part of the ecosystem now. We've got our customers on the one side, we've got our telecom partners on the other side. This is how it's going to be. We're going to have to be a part of a bigger ecosystem. We're going to have to break away from satellite operations, custom-built hardware, from our own standards, in air quotes, adopt open standards, adopt streamlined operations, automate what we're doing, be part of a bigger overall network, terrestrial and non-terrestrial. And this is what allows us then to deliver carrier-grade services, come up new business opportunities, and grow. Because grow we have to, otherwise we wouldn't be here. And if you're still not convinced this actually works, we've got a room in the other hall, room 150. We're going to be doing demos all day long today and tomorrow. Please drop by, free to see the system in action. It's real, it works, it's super exciting, and well, I hope to see you there. Thank you very much.